Hello and welcome to episode 3 of my Getting Started with Python programming course. So in the last episode we made this program which wasn't super interesting, but it did teach us some useful fundamental concepts about the language, such as our conditional language statements and things like type conversions, as well as comments, which are just a nifty little thing to know along the way. In this episode we're going to take a step back and look at something a little bit more straightforward and a little bit more directly useful to learning how to program, and that is going to be the Python REPL, or read, evaluate, print loop, which is just abbreviated to REPL for short. Now, this is a relatively complicated sounding name for something that is actually really simple, straightforward, easy to use, and really helpful for us when we're programming. And it's essentially a command line interface for talking to Python directly and finding information out about how our code is evaluated. So let's just jump into it. So to do this, what we're going to need to do is actually pull up our command line. We're not really going to be interacting with our text at all, our text editor at all in this episode. We're going to do everything through a command line interface. So you have two options here. You can open up your terminal that's integrated into VS Code using either the shortcut or the menu option and open it up here. Or if you prefer something a bit more separate or full screen, you can also search for a command prompt, or on Mac and Windows 11, you can search for terminal and open up a terminal that will work just like this. However, just for ease of simplicity, if you're not comfortable using the command prompt, you're probably easiest just to stay inside your Visual Studio window and keep it all in the one place. What I will do though is just resize this because we're going to need to be able to see it as it's the main focus of this video. So just simply going to use Control Shift and plus and just resize my whole window like this. Awesome. So now you can see that. Now, before we get started, I'm just going to go over a really basic command that will be useful. Because our terminal is going to get quite cluttered in this, it's going to be useful to know about the clear screen command. So we can type CLS in Windows and it will clear the terminal and reset it back to the start. If you're on Mac or Linux, you'll need to use the clear command, and that will also do the same thing. Okay, so to activate our Python REPL, or read, evaluate, print loop, we simply need to type Python into our command line and run it. This launches the Python Interactive Terminal, or shell. A shell is simply a command line program that you can interact with text. Okay, so you'll see here, it's just got these three arrows, and it's actually awaiting some input. And what this is this is actually a direct input into the Python virtual machine, or the Python program. We can type lines of code in here, and it will immediately evaluate them and print out an output. So we can do simple things like a print statement, for example, and we will do the standard hello world operation, which is very famous and important to do. And if we do this, you'll see that it just runs like our normal Python code did. If you remember, in our normal program that we wrote in the last episode, we had print statements all over the place. And this is a bit big, but let me just, there we go. We had print statements all over the place, and these were just used to print information to the screen. Well, in our interactive terminal, like we just have here, and it's cleared it for us, which is rather annoying, but doing it again, you'll see that it simply does the same thing. It just prints what we type inside it. So this is an interactive console. We can type in lines of code and have them evaluated for us. Let's do the other simple thing we know how to do, which is a variable declaration. So creating a variable x and setting it equal to 10, we can see that, well, nothing really happens. And that's because when we set a variable, there is no output. It just goes behind the scenes and creates a variable called x and sets it equal to 10. But what we can do is, now that we have run this line of code, it means that we can print out the value of x. You can see that it just recalled that we set it to 10. So we've got fully interactive code. Now, instead of just typing print, you can also just type the variable name straight back in, and it will just tell you what it evaluates to. That is the key behind the naming of this program. It's the read, evaluate, print loop. First, it reads in our line of code. It then evaluates what that line of code does, and it prints any output that comes from it. And then it just loops. We go back to the start, read another line, evaluate it, print it, loop. It's just a simple loop. So, when we just type in a variable name like x, in normal Python, this would give you an error. But because we're just simply evaluating what x is equal to, because we set it equal to 10, it tells us. So we can just use this as a shortcut way of just seeing what a variable contains. Really useful. And again, this works for all different types. In fact, we can do something like y equals, and then we can do our arithmetic operations like we saw in episode 1. and hit enter. And then if we wanted to see what the outcome of this formula is, we would just type y and see what the value of that is. Feel free to verify that on your calculator if you want. I can guarantee you it's correct. And in fact, I know it's correct because Python's command line like this can actually be used as a calculator. We can just straight away type in mathematical expressions such as 6 divided by 2, and it will just give us an output because all it's doing is reading this code, evaluating it, and giving us the output. In this case, 6 divided by 2 is obviously 3. We can do the same thing, 2 times 4. Any mathematical operation will work here, as long as Python supports it. So why am I showing you this? Because at the moment it doesn't seem incredibly helpful. Well, it's a really good way to prototype or test parts of Python code or language without writing a full program and having to run it and whatever. We can simply just test a bunch of stuff. The useful thing is, if we make a mistake, such as mistyping the print command, here you'll notice that our print command is missing a t and hit enter. Instead of crashing the whole program, just points out that there's an error and then just goes back to the start of the loop, which means we can just type it in again and fix our error. Obviously, I always screw up the typing of hello for some reason, so, we've got an error in our output, but that's just my fault, that's not the fault of Python. So yeah, this is a really useful way of just quickly evaluating and quickly testing code without having to, rechange the text in the file, save it to disk again, and then run it manually. It'll just continuously loop, and if there's errors, it'll just catch them, spit them out, and then we'll just start the loop again. Okay, so how do we get out of this? Because right now, you'll notice no matter what we put in, we can't really escape it. So the way you actually get out of it is just typing exit and calling it like a default Python function. So if you see here, we're calling exit, just open and close brackets like this, and it will exit out of the shell. Once we've exited out of the shell, then we will be able to do our clear screen command to just reset our terminal. You can't call clear screen from inside the Python REPL because it will try and evaluate all your input as Python code, whereas our clear screen command is actually an operating system command. So we need to exit the shell before we can run it. Okay, so running our Python shell again, which is, you'll notice, just the keyword Python. You know how sometimes when we're trying to run our program, we would say something like python main.py, where this is a file that we want to run? Well, if we just run Python but without a file, then it will just ask for input. If we run it with a file, then what it actually does is it just pushes all the text in that file through this program in a very similar way. As you can see, we're directly interacting with the very thing that actually evaluates our text code. It's actually the same program, so everything that works in one will work in the other. Okay, so one of the more tricky concepts we've gone over so far is the idea of variable data types and type conversions. It's tricky not because the concept is fundamentally hard, but because it's quite challenging sometimes to know or see what data type a certain variable is. Because it's done in the background and abstracted away from us, if we look at this code, sometimes it's not immediately obvious what data type choice would be. But in fact, choice is an integer because we have converted it to be an integer. But it's not immediately obvious looking at this that might be the case. So we can actually use the read evaluate print loop to find out about data types and learn things about them. So, for example, if I define a variable called x once again, and we'll set it equal to 10, we can ask Python what this data type is. And the way we do this is by using the type function. So using the word type, as in what type of variable is this, and then an open bracket and a close bracket around the thing that we're trying to analyze, we'll see that, okay, x, the variable x, is an integer type, or int for short. Don't worry about this class bit, it's technically telling us some information about what kind of object it is, but that's a bit too advanced for now, so just worry about what it calls it. In this case, type x is int. Okay, cool. So what are the other types we learnt about? Well, we also saw strings and we saw floats. So let's see how that works. So if I ask for the type of, and then I give it a string, always typing it wrong, of course, you'll see that if we ask for the type of something contained in these quotes, you'll see it's a str or string type. And last but not least, if I ask for the type of, say, a floating point variable or a decimal number, you'll see that it is a float type. So as you can see, Python is actually correctly identifying and storing these as different types. Even though to us it might not be obvious at first, we can use this type command, ask for the type, which is really useful. Now, This is not necessarily the most helpful feature in the world, but I think it is helpful to try and remind you when you're learning how to code. You can sort of pull this up in your terminal and type some things out and just check what data types you get given. For example, what happens if we divide a whole number by another whole number, but the output isn't a whole number? What data type do we get? So for example, you know, 4 is divisible by 2. And if we run this, we expect that we just get 2, and it looks kind of like it's a decimal, so that's sort of a clue as to what happens. But these are both integers, right? So let's just quickly check. What is the type of a single number by itself? Well, that is an integer. And what is the type of the other integer by itself? This is an integer. So you can see here that 4 and 2 are both integers. But when we divide them with each other, it looks like we get given a float as an output. So let's check if this is actually true. We can just ask for the type of 4 divided by 2, and what Python will do is it will first do what's inside the brackets and evaluate that, and then it will get the type of that output. If we hit enter, we see that we get a float. So this is an example of a case where it's a little bit less obvious what the certain output type of a operation would be in Python, where we have 2 integers, but the output is a float. Now, it's not too often that this will cause you bugs or issues or problems, because for the most part, Python is pretty smart at converting between types where it can and where it has enough information to infer the desired type conversion. And only sometimes do you need to do the explicit ones, like we saw in the last episode, of having to explicitly cast to an integer. But, both are still important things to consider. However, this is just a demonstration of ways we can think about or remember or find out what the output types of an operation are, and it's really fun to play around with. The other thing, and I'm just going to quickly exit and clear my screen. Oops. Perhaps if I can type it correctly, there we go. Exit and clear my screen. Oh my goodness. And run our terminal again. The other thing that this can be really useful for is exploring other functions and stuff built into Python. So far, the only real functions we've seen is like print, and we've seen the integer type conversion, and maybe 1 or 2 others. We've seen type as a function, but Python actually has a whole bunch of built-in features which can help you do all sorts of different things. So let's quickly sort of have a look at the math library. So we haven't covered libraries before, and we will go into them in greater depth at another episode. But for now, what I just want to go over is the basic idea of it. So in Python, a library, or a module as they're more correctly known in Python terms, is a collection of code that someone else has written, which is stored somewhere else, that we would like to access and use for our own purposes. So programming is all about collaboration, and if something's already been done once, there's no point reinventing the wheel. So you'll find for a lot of basic things in programming, there's already code out there that will do the job. So we're going to use this new keyword called import, and we're going to say import math. Okay, and hit enter. And what that changes is basically nothing. You won't see any output or anything like that. But what that's doing is it's finding a module called math on your computer, and this is installed when you install Python. And it's basically just copying all the code that's stored in this math module and sort of pasting it in the background so that we can call all the functions and things that are defined in this maths library. And this is really useful because it gives us access to a lot of different mathematical functions. For example, the most common application maybe potentially for this library is to use trig functions or trigonometry functions. So we can do math.sine, for example, and we can call a sine function with some input. Now, the input in programming, you'll always use radians. I don't want to get too bogged down in the maths. It's not important. But this is just a way of showing that inside a module called math, we can access a function called sine. And we can give it an input, and it will give us the sine of that angle. Now, this is just a demonstration of the way that we can just test what features and how certain functions work without having to necessarily write a full-on piece of code. So we could also say, okay, well, I want to know what the output of that is. So we can just say, okay, so what is the output type of this function? And you can say, okay, well, as we could probably tell just by looking at it, that math.sine outputs a floating point integer or a decimal, for example. So yeah, this is really just a useful tool that you can use to analyze and test different libraries. So yeah, it's pretty simple. That's basically all I have to say about it. So you can type in things and have it evaluated. You can define variables and do mathematical operations to see the answers, and you can find out the types of different variables and information, such as the type of x, and it'll tell you it's an integer. At the moment, you might not see too many direct uses for it, but it's useful to remember that we have this interactive environment, because when we do more and more complicated coding, you'll start to find little useful ways you can use this to test snippets of code and to test for outcomes and ideas. So that's basically it for this episode. I know it was a bit boring. In the next episode, we won't actually be writing more code because I want to basically go over everything we've learned so far and summarize it and actually just say, how does Python work? What's really happening under the hood? Because once you understand that, it will make it a lot easier to sort of extend those ideas and take them further. All right, thanks for watching, and I'll see you in the next one.